Hi Noah, who didn't come to school because you left your wallet when you came home from the concert. Here's what. When we were doing the transformations, I kept saying, put the important points down, right? And I said, there are important points on your graph. Make sure you have those. Well, those important points actually have a name. The name is not important points. The name is actually critical points, right? And there are points on our graphs that are special, where things are happening, right? Where there's weird stuff happening. Because remember, we have infinite points, but there are some points that are more valuable than others. And those critical points are two things that happen. Either the graph changes its direction or it changes its shape, right? It changes its direction or its shape. Now, the first ones are the most obvious, and we call those extrema. And really, another word that we use for those sometimes is vertex, right? Because what they are is a place where our graph is like, hey, I was going up, 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 like a little roller coaster, and now I'm heading down, right? Those points right here, where it changes direction, where exciting things happen on a roller coaster, those are called extrema, right? So extrema is where the graph changes direction, right? And that's important. And they are either the lowest point, which is a minimum, like down here, or they're a high point, a maximum, just like on a roller coaster, right? They're just like on a roller coaster. Now, the other one is the one I talked about, and I kept saying it's a point of inflection, meaning it's like something's happening, but it's not as obvious, right? So it's like when you're on the roller coaster and you know how like you go and you're going and you get that one part where it takes a minute and it kind of flattens out and then it keeps on going. That flat kind of boring part, we call that a point of inflection. And what's happening there, if you notice, my graph looks kind of curvy and then it's curving the other direction. It's changing its shape a little bit. It's changing its shape. And you remember last year when we did that bouncing and wiggling, I'd say, hey, that's a wiggling spot, and it goes like that. Those are inflection points. That means, hey, your graph is taking a little breather, or it's changing direction, or it's changing its shape. It's still going down, right? But your little roller coaster is kind of stopped for a second, and then it keeps on going. Yeah. Yes, we're going to talk about that. Like you got me set up, because when we talk about min and max, there are two types, right? So let's talk about Mount Diablo. We love her. She's our mountain. She's special to us. We think of her as pretty high. She is a sad, pathetic little mountain when you compare her to other mountains, right? She's barely the tallest in the Bay Area. She's certainly the tallest, like in Northern California. There's higher ones in the Sierras, and she's definitely not the tallest, even in the state of California, certainly not the United States. But we love her just the same, and here's why. Because she is what we call a relative maximum. For our area, she's the tallest, right? So in this area of the graph, that baby's the tallest. We're proud of her. But overall, the very tallest point is called the absolute maximum, right? The very tallest, that's going to be an absolute maximum. So to be fair, the absolute maximum in the world is not Mount Diablo. It would be Everest, right? Mount Everest would be the absolute maximum, right? Now, here's what happens on this guy. Just like Lucas was saying, that's a minimum, but this graph goes to infinity. That's the true minimum. So this would be, when we talk about it on the next slide, that would be a relative minimum, right? It's pretty good minimum, but not the lowest, right? So we can do the same things with minimum values. We can have a relative minimum, relative. I'm just adding, you know what? I'm literally just writing letters. They don't even go together. Relative minimum, right? Like this guy, but the lowest point is the absolute. So, for example, if you go to Death Valley is one of the lowest places in the United States, but the lowest place on Earth is Mariana's Trench, right? That is the lowest place where you're not in lava, and that is the absolute minimum. Okay, so here's why. Yes.
So like that one specifically, right? So the point, does that mean absolute maximum for that graph?
Yes, that is exactly right. So that's a great point. This would be a that would be a relative max because my true maximum is infinite, right? And you know what? We don't really list it. We just say all it has is a relative. We just say that's a relative. Okay, everyone's got a Chromebook out. Get a Chromebook out or get a neighbor with a Chromebook out. You know what? I'm even going to go the next step. If you don't have a Chromebook and you want to get your phone out, you know you can do Desmos on your phone, or you can get a graphing calculator. But we want to use tech for this.
Can I get both?
No. I'm trying to.
Is there a Desmos app?
I don't know. I just go www. I think it might have an app.
I use that app every day.
I love Desmos. Desmos is my good one. So here's why. Before we start, we need to think about a couple things. I need everyone's attention before we start. You guys ready? So we're going to graph this baby. Now I'm going to remind you of a couple things. When we have polynomials, anything to more than like an x, right? X squared. I don't know if you remember this, but we did talk about it. You're going to get one less term than the highest number of exponents. So in other words, this bad boy is a U graph, right? He's a U graph. He's squared. That means he has one important point. He has one extrema. And you're like, why does that matter? Because sometimes when you graph it, you can't see the whole thing. So you've got to kind of in your mind think, like this guy, he's going to have 3 important points that we're going to look for. It's always one less than the biggest exponent. And I'm going to show you when I graph it up here, if I didn't keep my eye out for that, I might not get enough. My graph might not show you enough. So let's start here. Let's put this, the number 1, in our little Desmos. And you're going to see it is so nice to get our maximum and minimum. Love punching in Desmos because it is super easy to do. 16x plus 27. Okay, here we go. That's what he looks like. Now, here's what's cool about this. It's got this really cool feature. Come up here. Maybe I'll do it up here. So your graph may just look like this. Let's see if I can make it happen. Nope, it's not doing it. It's already showing it. Some graphs, you don't have, it's just a graph. It looks all green and normal. But if you tap on it, Desmos automatically puts the important points on right away for you. It's like, hey, look, there's some important points. There's an important point. So if you want to get your minimum, all you literally have to do is come over, touch it, and it shows up right there. Now, if you're using a graphic calculator, you got to go into calc and have it do max and min, which is fine, but the Desmos does it automatically, right? So on this one, there is no place lower on this graph. That is absolutely the lowest. So what we're going to write is that it has an absolute minimum at 4, -5. So easy, right? Okay, the next one's a little tricky. Can you please put the next one into your calculator, and you're going to be looking for 3 magical points because this is to the 4th, so we're going to drop down 3. So I want you to look for those 3 magical points, right? Can't believe I'm like able to like do so many weird things here. Let's get rid of this dude. Get out of here, dude. I don't care about you. So I think, because look, I got my graph kind of squished on here. Watch what's going to happen when I do this. Y equals negative x to the, you know, that little caret. You guys all know that. You guys are just doing this. You know more than me. I get really tight. Did you notice that? I'm really awful. Like I'm super slow. And my daughter says watching me text is painful. Because you text like all day. So here's what happened when I first did this earlier today. This was what my graph looked like. And I'm like, oh, okay, I just have one thing, I'm done. And someone goes, I don't think you're looking at the whole graph. So that's why it's important, I kind of missed letters there, to watch, it's to the 4th degree, so there are going to be 3 important points. So if your graph is not showing them all, there they all are. And look, my graph is not showing any of them, so all I have to do is touch the graph, and they magically show up, right? So on your either whiteboard desk or somewhere, can you put, you're going to have 3 things happening. Looks like I have an absolute max, a relative max, and a relative minimum. Not an absolute minimum because it goes to infinity, right? So here we go. I'm going to start here. That is my absolute max. Absolute max at negative 1.52. I don't even care about that. 1.5, comma, 2.9. I'm going to have a relative max right there at 1.27 and negative 2.7. And finally, I'm going to have a relative min, and I'm going to steal it from that dude right there. I'm not going to write it because I'm lazy. Right? Easy. Yeah, super easy. It's like, the absolute min would be infinity because it's going negative infinity, and we don't have to write it, right? Very nice. Easy? Yeah? We got one more bit of what's it called to learn? Of vocab. So we're switching back. We're going to do this. And the next one I actually like a little bit better. The last thing we're going to talk about is increasing and decreasing. We're going to be looking only side to side. We love this. So what we're going to be talking about is side to side, where is our graph going up? And side to side, where is our graph going flat? And where is it going down? Now, I'm going to be honest. I'm a kind of a dumbass on these. I have a tendency to look at this and say, look, it's going up. And it's like, oh, look, it's going down. Yeah, that's wrong. So here's what I do to make sure I don't blow this. If your graph is increasing, when you write your name on it, your name goes up. If your graph is Gamer, that's my name. If your graph is decreasing, when you write your name goes down. It's really hard to mess that up, but it helps you, right? So what we're going to do is we're going to talk side to side, and we're only going to use parentheses here because this point is really, it's both increasing and it's flattening out, so it doesn't go to either one. So watch what we're going to say. From negative infinity all the way to negative 1, my graph is increasing. Does that make sense? Do I have to worry about brackets or anything? Nope. Parentheses, parentheses. Do I have to worry about up and down? Nope. Side to side. My graph is solid from here to here. It's nice and flat. It's constant. So from negative 1 all the way to 4. Again, I don't have to use a bracket because it's included. It's both kind of increasing right to the point you get there, and then maybe it flattens out. And then finally, it's going down from 4 all the way to infinity. Now, someone said, but it's going down. But we're talking side to side. We're only going to be using negative and positive infinity side to side. It's really, really nice, right? It's really nice and really easy, right? But it's kind of a cool thing that we are going to use all year. So, you ready to try one? I got a nice little graph for you. Here we go. Okay. You're going to have a little spot right there. Can you write for me where your increasing interval is and where you're decreasing. Again, I'm an idiot. I'm like, oh, look, it's going up. No, I write my name on it, and it's like, oh, wait, it's going down. It's going down. I swear I have to do that. I don't know. I think it's a spatial thing. I'm going to tell myself that I'm not just totally stupid. So negative infinity, down, 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 down. 1, 2, 3, all the way to 3. Once I hit 3, my little roller coaster starts going up all the way to heaven. I got one last example, and then I'm going to try to get your candy out. I'm going to make sure I'm going to put the right tests in, and I'm going to say, did you all do your homework? Yes, okay, because you know what, there are a lot of you who slept in, and or didn't come to class, so I'm going to give you that points for it. Okay, so here's what. Sometimes you don't have both intervals. Take a look at this guy. Here's me writing my name. Phew. So on this one, this bad boy never going to go down. It's like the saddest roller coaster that just keeps going up, 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 up. But we never actually get to get the part where it goes down. So there is no decreasing interval. It is just negative infinity to positive infinity. You know, most lines are like that. If I'm graphing a line, same thing. It's going to go negative infinity to positive infinity. I am done. I'm going to talk to you about your homework. It is easy. You will finish in class probably. The answers are on your desk, but I will also post them later. Goodbye to my people who slept in. Noah.